Good day to all the dear students. Today we are going to start chapter number 12, similar triangles. The first part we are going to start, in which I have explained you the definition of similar triangles and also theorem 1, which is very important, and I have started exercise 12b according to theorem 1. Chapter 12, similar triangles. First of all, we learn here which two shapes are said to be similar. So here you can see on the board I have drawn three different shapes here. First is circle with some radius and the another circle with the smaller radius. So here these two figures are in shape same, but in size they are different. Similarly, this is the square whose side is 3 centimeter and this is the square whose side is 1 centimeter. So here both the shapes are same, squares, but the size are different. Similarly, you can see the third figure, which is of two triangles. So here this triangle is having, suppose here is 5 centimeter, here is 4 centimeter and here is 4 centimeter, you can say. So in correspondence with it, this is 2.5 centimeter, 2 centimeter and 2 centimeters. It means this is the bigger triangle and this is the smaller triangle. Its sizes are smaller than the bigger one. Also, you can say in the first circle, the radius is 2 centimeter and here radius is 1 centimeter. So, you can understand here, students, that if two shapes are same but the sizes are different, we can say they are similar figures. So now in this chapter we are going to learn about similar triangles, which is very important to understand this concept. So here I have written definition of similarity of triangles. You can see here what it is written, that two triangles are said to be similar if corresponding angles are equal in measures and ratio of corresponding sides are equal. So now let us understand by the figure I have drawn. I have drawn here two triangles ABC and DEF. So students, what the first line says, that in these two triangles ABC and DEF, angle A is equal to angle D in size, angle B is equal to angle E, and angle C is equal to angle F. So here I can write angle A equal to angle D, angle B equals angle E, angle C equals angle F. Equal means if it is 30 degree, this is also 30. If it is 50 degree, this is also 50. And if it is 100, this is also 100. Likewise, this is one example I am giving, not actually 30, 40 and 100. But this way, if we take corresponding angles equal, and another condition, it is written that ratio of corresponding sides are equal. What does it mean? Let's suppose AB ratio DE. If I have taken first ABC triangle side AB, then the smaller triangle is DE. Then BC corresponding side is EF and AC corresponding side is DF. So you can see this is the ratio I have taken, bigger size and smaller size, bigger and smaller, like that. So here we can say these two triangles are similar when the corresponding angles are equal and the ratio of the corresponding sides are also equal. So this is very important concept and we are going to solve some questions on it. Also, one more thing, how to denote it. So I write here triangle ABC is similar to triangle DEF. This is the similarity symbol. How we read it? We read it as triangle ABC is similar to. This is similar to triangle DEF. Likewise. So here I am taking one more example of triangle ABC and triangle PQR. Now students, it is not possible that every time A is equal to P, B is equal to Q and C is equal to R angle. It can be like this. You see here, if A is equal to angle Q, then B is equal to angle R and C, that is the third angle, is equal to angle P. So the order is different here. Angle A is equal to angle Q, then angle B is equal to angle R and angle C is equal to angle P, like this. And you can say the corresponding sides also in order like that, like here AB. So here will be QR. Between these two angles you can see this that signs I have drawn. So AB ratio QR we have to write. This order is very important. Then BC, that will be PR. BC upon PR and AC upon PQ, like that. So now we can write triangle ABC. This triangle ABC is similar to which order? We have to write similar to order. You see, A means this. So here will be Q. Instead of A, I can write Q because A is equal to Q. Then B. So B, then R. So I have to write here QRP. This way you can check now. This AB, then it is QR. You see, AB, QR. Then another is BC, then RP or PR you can write. And the third one is AC. Then here is QP or PQ. So here we can say the corresponding angles and sides are in ratio and equal. So we have to write the order in accordance with the angles and sides we have taken. So here I have written triangle ABC similar to triangle QRP. One size is big and the other is smaller. So I can give you the other examples, like sometimes you can see the shadow of yourself and a pole. So both are same type of figures but the sizes are different. So that real examples also you can see in similar triangles. Now here we have studied about two similar triangles. So I am again recalling the conditions, students. Which two conditions we have to remember for the similarity of triangles? If the corresponding angles are equal in measure, like A is equal to Q, B is equal to R and C is equal to angle P, and the corresponding sides ratio, or we can say if the corresponding sides are in proportional, then the two triangles are said to be in similar triangles. So again, the first condition is the three of the corresponding angles measure should be same or equal and three of the corresponding sides are in proportional. Then triangles are similar. Now we have some axioms for similarity of triangles. Some students also misunderstand the similarity of triangles with congruency. So students, in congruent triangles, not the sizes are different. The sizes are also same, exactly same in both the triangles. Then only the congruency conditions are applied. But here in similar triangles, the sizes are different. You can see in figure. One is big, the other is small. So in that case also we can say they are similar by some conditions. So these are the main two conditions, but we have some similarity axioms here that you can see, axioms for similarity of triangle. So let us see the first one, that is AAA axiom of similarity. In this, I have drawn two triangles. One is triangle ABC, other is triangle DEF. So their sizes are different. But if angle A is equal to angle D in size or the measure, and angle B is equal to angle E, means two angles of triangles are same in measure, then by angle sum property we can say the third angle also equal in size. That is our angle sum property. We have already learnt that if two angles are similar, then the third one also always equal in measure, and the corresponding sides ratio. So I am writing what is axiom AAA, means if two angles A is equal to D and B is equal to angle E, then the third is always equal in measure. And also the corresponding sides ratio, that is AB upon DE is equal to BC upon EF is equal to AC upon DF. These two conditions are proved here. So we can say AAA axiom, we can say the triangles are similar. Now we'll see the second SAS axiom. That is our second figure. You see triangle ABC and triangle DEF. So here angle A is equal to angle D. These are the two angles equal in measure, and the including this angle included two sides AB, DE, AC, DF. Then we write here angle A is equal to angle D, and the corresponding sides like AB upon DE. This is proportional to DE, and AC upon DF. So these two sides and included angle are equal. Then we can say by SAS, side angle side, side angle side axiom, these two triangles are said to be similar. So this is our second axiom. Now third axiom, that is SSS axiom of similarity. So here two triangles, you can see triangle ABC and triangle DEF. SSS means side, side, side. It means AB ratio DE, BC ratio EF, and AC ratio DF. All three are ratios equal, like AB ratio DE, BC ratio EF, and AC ratio DF. Then we can say that by SSS axiom, these two triangles are said to be similar. Here, now if three of the sides are in proportion in triangles, then we can say their corresponding angles are also equal. That is automatically now as the sides are in proportion, we can write angles also equal. So in three of the case, triangle ABC is similar to triangle DEF by different conditions. First is AAA, second is SAS, and the third is SSS. But remember, it is not congruent triangles, they are similar triangles. So here now we are going to start theorem number 1. Theorem 1 statement is given: a straight line drawn parallel to one side of triangle. This is the straight line drawn parallel to BC, that is the one side of triangle ABC, divides the other two sides. These are the other two sides, AB and AC, divides the other two sides proportionately. Proportionately means AD upon DB is equal to AE upon EC. Means what we are given here, we are given that in triangle ABC, DE parallel to BC. Parallel means you all know the distance between them at any point is always same. So DE parallel to BC, and we want to prove that AD upon DB. AD means this and DB is equal to AE upon EC. So now let us start with our proof. So here you have to understand this, students, because using this theorem we have some examples we are going to solve. So now in triangle ABC, the bigger one, and triangle ADE, the smaller one, ADE. In these two triangles, which angles are equal? We have to see here. First is this angle D is equal to angle B. Why? Because they form corresponding angles. These are the parallel lines. So this angle and this angle are forming parallel angles. Corresponding angles. Now next is the another angle is E is equal to C. Again they form corresponding angles. So I am writing angle ABC. ABC equal to angle ADE. Another is ACB. Angle ACB equal to angle AED. This way, the reason is they form corresponding angles as two sides are in parallel given to us. Okay, next one, if these two angles are parallel, that angle A is common in both the triangles. So we can write the third angle that is common for both the triangles. So I am writing angle BAC, the big one, is equal to the smaller one DAE angle. They are the common. So here I write in the bracket common. So here we have shown three of the angles of two triangles AD and ABC equal in measure. So we can write triangle ABC is similar to triangle ADE. So we have shown two triangles similar here. Then here we will take the corresponding sides ratio. You can see here this is AB upon AD. You have to check from here only where you write the similarity. Then is equal to AC. This is the big side AC upon AE. This is the ratio we have taken of two sides, that is the corresponding sides. Now what is AB but? AB here in the figure is divided in two parts, AD plus DB, and AC is divided as AE plus EC. So here we write instead of AB, AD plus DB upon AD is equal to this AC also divided as AE plus EC upon AE, like this. Now we take separate ratios. Here I take separate ratios. So this is AD upon AD plus DB upon AD. The separate ratios are taken here. You can see both the sides. Here also AE upon AE plus EC upon AE, this way. Then we have this to be cancelled. So writing 1 plus dB upon AD is equal to, here also 1 plus EC upon AE. Now both the sides we have 1 also get cut. So what we are left with, dB upon AD is equal to EC upon AE. This is with what we have left. Now I can take reciprocal of it. So taking reciprocal, I get AD upon dB is equal to AE upon EC. So this is what we want to prove as our result. You can see this is what I want to prove here, that in a triangle, see, this is what our to prove part and what we have proved here. So the whole proof is completed. This result you have to remember. Whenever you are given a parallel line to the one side of the triangle, then it divides proportionally like this, AD upon DB and AE upon EC. Now students, converse part of this theorem number 1, that is theorem number 2, is in a converse way. If there is a line drawn on a which is drawn to the parallel to one side, or you can say if a line drawn is cutting the other two lines proportionally, then that line is parallel to the third line. So that is our theorem number 2, which is the converse part of theorem 1. So this theorem is straightway, if a line given parallel to the one side, it divides the other two sides proportionally, and in converse way, if one line that divides the two sides proportionally, then that line is parallel to the third line. So likewise, the straight theorem is 1 and the converse is theorem number 2. Students, this year in similar triangles, size transformation, constructions as well as questions are not included in our syllabus. So we have to start with our exercise 12B. So in exercise 12B, question number 1, I have taken second. The question is say that in each question of the 3 triangles, here we are given 3 triangles, name the one that is different, that is not similar to other two. So here we have to give the name, like this is your first A, this is B and this is C. So which one is different from other two? So let us start how to solve it. This is 100 degree, this is 45 degree. So the third angle must be of 35 degree. By angle sum property, you can add 100 plus 45, 145. And subtract from 180 so that I get 35 degree. Similarly, in other triangle, one angle is of 35 degree, another is of 100 degree. So by adding them, I get 135 degree. Now subtract it from 180 degree so that I get the third angle as 45 degree. So you can say that in first triangle A and triangle B, all the 3 angles are similar. So by AAA axiom of similarity, we can say that first and A and B are similar to each other. But what about the third triangle? Here is 25 degree and 45 degree. The sum of them is 70. You can check 70 degree, and so the third angle must be of 110 degree. So then it makes a angle sum property, or the sum of 3 angles is 180 degree. So you can say these two are similar, but C figure or triangle C is not similar. So it is different from A and B. So in our first question, second one, answer is C is different from other 2 triangles A and B. This way we can solve our question 1 second. So similarly students, first and third triangles you can find out which one is different. Here exercise 12b question number 2. Second I have drawn on the board. Figure is already drawn. The question is, write down the ratio of the corresponding sides for each pair of triangles and check that it is same ratio. So here two figures like MLN and RPQ, these two triangles are given. What we have to check? We have to check the corresponding sides ratio are same or not and how much it is. So first of all, you see that 60 degree, 60 degree, 30 degree, 30 degree and 90, 90 means all angles are same. So MLN is similar to RPQ. So now we can take corresponding sides ratio. So here I have taken first LN ratio PQ, LN ratio PQ. So LN 14 mm and 2.1 is converted into mm as 21 mm. So that by cancellation I get 7 2s are 7 3s are 2 by 3. Now next figure, next side is Mn upon RQ. So that is 8 upon 1.2 centimeter converted into mm as 12 and then cut it upside down by 4 2s are 4 3s are. And the third side, that is LM upon PR. So LM is 16 mm and PR is 24 mm. 2.4 converted in mm as 24 mm. So by cutting here, this is 8 2s are 8 3s are. So likewise we can say three of the sides are in proportion and their ratios are 2:3. You can check all of their ratio is 2:3. So the answer of this question is all the three sides of the two triangles are in ratio 2:3. So here you can check how we have to solve. So same way students, second, first you can solve by yourself.